Hello, you are welcome to my class today. I'm Dr. Kingsley. Please always subscribe, like and share my videos. Now today, I'll be taking on the topic Dalton's law of partial pressure. What is Dalton's law of partial pressure? Dalton's law of partial pressure states that if there are mixture of gases which do not react chemically together, the total pressure exerted by the mixture is equal to the partial pressure of the individual gases that makes up the mixture. What we mean by this is, if we have a container containing three gases, say A, B, and C, we know that A will be exerting pressure, B will be exerting pressure, and C will also be exerting its own pressure on the walls of the container. Now, the total pressure that will be exerted by these gases will be exactly equal to the pressure exerted by A alone, which is called the partial pressure of A, plus the pressure exerted by B alone, which is the partial pressure of B, then plus the pressure exerted by C alone, which is the partial pressure of C. What we simply mean is this: the total pressure exerted by this mixture of three gases will be equal to partial pressure of gas A, pressure exerted by A alone, plus partial pressure of B plus partial pressure of gas C. Remember from ideal gas equation, pressure multiplied by volume is equal to nRT. If we make pressure the subject, pressure will be equal to nRT divided by V. Remember, these three gases, they are in the same container, the same environment, so their volume are the same because they have the same volume. Each of them will take the same volume of the container. Then temperature will be the same because they are also within the same environment. So you can now see that R, T, and V are the same for these three gases. R is a constant. What differs for each of these gases is likely to be the pressure and the what? Number of mole. Then how do we get the partial pressure of gas A? The partial pressure of gas A, which is pressure of A, will be equal to number of moles of gas A, RT, then divided by the volume. Then the partial pressure of gas B, using this formula, will be equal to pressure of gas B, which is equal to number of moles of gas B, then RT divided by volume. The pressure of C will be equal to number of moles of C, RT divided by V. Now, total pressure, as you see, total pressure, PT, is equal to pressure of A plus pressure of B plus pressure of C. Now, if we put all this into this equation, you see that the total pressure will be equals to pressure of A is NART over V. So we are having NART over V. Then plus pressure of B, which is what? NB RT over V. Then plus pressure of C, that is PC, is what? NC RT over V. What is common? If you look at the right hand side, you find out that what? RT over V is common to all of them. So let us factor it out. It simply means that total pressure will now become RT over V, which is common to all of them. Now, if you have RT over V common, if you factor out RT over V, what will remain is NA. So we'll be having NA plus NB plus what? NC. This is the formula to calculate what? The total pressure exerted by gases in Dalton's law of partial pressure. Now, let us take a question or two. Okay, question 1. Which of these mixture of gases will not obey Dalton's law of partial pressure? Which of this mixture will not obey Dalton's law of partial pressure? A, let's say we have mixture of nitrogen gas and oxygen gas. B, mixture of nitrogen gas and carbon dioxide. C, mixture of hydrogen gas. Okay, let me take mixture of argon. Argon is a gas, a rare gas, and oxygen. Then D, mixture of hydrogen gas. Okay, or we can take mixture of carbon dioxide gas, and okay, let's take water vapor. Water vapor, that is the gaseous water. Now if you look at this, you find out that what, that these two gases cannot react together, these two cannot react, these two cannot react, but you can take carbon dioxide and water, they will react together, of course, to give us what, H2CO3. so these two gases, they can react together, and Dalton's law of partial pressure says the mixture of gases must not react together. So this is the answer. This mixture of gases, okay, will not obey the Dalton's law of partial pressure. Now let me take question 2. Let me make it a calculation. Let's say 0.2 mole, okay, 0.2, comma 1.5 and 0.3 moles of gas A, B, and C are mixed together in a container of 500 centimeter cube at 27 degree Celsius. At 27 degree Celsius. Full stop. Find the total pressure. Find the total pressure exerted by these gases. We want to find the total pressure exerted by these gases. Now, we can see that number of mole of gas A is equals to 0.2. Number of moles of gas B is equals to 1.5. Number of moles of gas C is 0.3. Now, from here, our volume is 500 centimeter cube, and our temperature T is equals to 27 degree Celsius. Please remember that molar gas constant is equal to 0.0821. Okay, now if we put it into this equation here, we will see that what, that our total pressure P total is equals to RT over V, number of moles of A plus number of moles of B plus number of moles of C. So that means that the total pressure will be equals to molar gas constant 0.0821 multiplied by the temperature. The temperature is 27 degrees Celsius. You convert it to Kelvin. 27 degrees Celsius plus 273 will give you 300 Kelvin. Then multiply by, okay, 300 Kelvin divided by the volume, which is 500. Then number of moles of A is 0.2 plus 1.5 plus what? Plus 0.3. Now, if you simplify this equation, what we have is that total pressure will be equals to 98.52. Okay? ATM. Okay? Yes. Please, the volume they gave us here is 500 centimeter cube. We are supposed to convert it to dm cube. How do we convert 500 centimeter cube to dm cube? That means we are supposed to divide this by what? 1000. Yes, the answer still remains the same. Okay, because I've already calculated it earlier. So 98.52 ATM. We divided by 500 because it's in centimeter cube. We are supposed to use, of course, dm cube. All right. Now let us go on this class. We are on Dalton's law of partial pressure. There are some other things that we can do. Let us take a ratio of partial pressure of one of the gas divided by what? The total pressure. Now let me use gas A. If I take a ratio of what? Partial pressure of gas A divided by the total pressure, what am I going to have? It will be equals to partial pressure of gas A. Remember, is number of moles of gas A, RT over V, then divided by the total pressure of the three gases, which is what? Number of moles of gas A, okay, that is RT over V into number of moles of gas A plus number of moles of gas B plus number of moles of gas what? C. Alright, that is okay. This is what? The partial pressure of gas A. This is the partial pressure of gas what? The total pressure. Partial pressure of gas A divided by the total pressure. Is there anything common at the numerator and the denominator that we can cancel? Yes. There is RT over V here, there is RT over V here. So they can do what? They can cancel out. So you can now see that what? Partial pressure of gas A over what? Over total pressure will be equals to what is remaining here is what? Number of moles of what? Gas A over what we have here down is what? Number of moles of gas A plus number of moles of B plus number of moles of what? Of gas C. Now, look at this. Number of moles of a gas over total number of mole is what we have here. This is number of moles of gas A divided by the total number of mole. The number of moles of gas A divided by the total number of mole is what we call the mole fraction of gas A. So remember, Ma over Na plus Nb plus Nc is equals to mole fraction of gas A, and it is represented by what? By Xa. So anytime you see Xa, it means mole fraction of gas A. Now, if that is truth, we can now see that what? Partial pressure of gas A divided by the total pressure will be equals to. Instead of this, we represent it with what? With a mole fraction of gas what? A. So we put Xa. If we make the partial pressure of gas A the subject of formula, our partial pressure of A will become equals to total pressure multiplied by mole fraction of gas A. So this is the same for all the gases. Partial pressure of gas A is equals to total pressure multiplied by mole fraction of gas A. Also, partial pressure of gas B will be equals to total pressure multiplied by mole fraction of B. The same thing holds for what? For C. So it is important for us to note this. Now what do? We can take a question for partial pressure. Now, let's take one question. Let's say 3 gases of number of moles 0.1, 0.2 and 0.3 are mixed together in a container, full stop, if the total pressure exerted by the gases is 60 atm, full stop. Find the partial pressure find the partial pressure of the first of the gas. Okay, find the partial pressure of the gas having number of moles of 0.2. All right, let us solve here. So you can see there are three gases and they were given the number of moles, and they gave us the total pressure exerted by these gases. We are to find the what? The partial pressure of the gas that have the number of mole of 0.2. You can agree with me that what? That if we take this gas here to be A, and we take this one to be B, and take this one to be C, what it simply means that we are looking for the partial pressure of gas B. So what is the partial pressure of gas B? It will be equals to total pressure multiplied by mole fraction of gas B. So that means that partial pressure of B will be equals to total pressure, which is 60. What is mole fraction of gas B? Mole fraction of gas B will be number of moles of gas B divided by the total number of moles. So we'll be having 0.2 divided by 0.1 plus 0.2 plus 0.3. So when you do this, you see that the partial pressure of B will be equals to 60 into 0.2 over, if you add all this, you have 0.6. So, okay, so that will be equals to 60 multiplied by 1 over 3. So partial pressure of B will be equals to 20 atm exactly. All right, thank you very much. I hope you like this class. Please do help me to subscribe, share, okay, and like this video. Also, you can drop your questions on the comment section. Thank you.